Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at network transmission quality. We'll be discussing the purpose of quality of service, prioritizing traffic, bandwidth, congestion, delay, jitter, and then packet loss. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Quality of service. What is it and why do we need it? QoS allows us to prioritize certain types of traffic over others. Different types of traffic place different demands on the network. Voice and video traffic require greater resources from the network. They require more bandwidth to achieve the quality that is needed in a phone call or a streaming video. Financial transactions are time sensitive and they have greater needs than regular traffic like a web page or an email. In this diagram, we're going to give you a general concept on how this works. Packets are buffered at the router right here, so this is where they're going to be buffered. And 3 priority queues have been established. The high priority queue, the medium priority queue, and the low priority queue. Voice over IP traffic in the higher priority queue is given a higher priority. So more of those packets are allowed to be forwarded across the network. Financial transactions, which are also time sensitive, are given a higher priority. We're giving it medium priority. And more of those are allowed as well. And lastly, any bandwidth is left for the static web pages, and that is giving a low priority. And when you see the stream coming out of the router, you can see that we have more high priorities here. That's the red ones here. We have 5 high priorities, and then we have 1, 2, 3 medium priorities and 1 low priority. Because the voice had a high priority, it gets to the front of the line, and if there's more voice there, it can travel across the network more frequently. When do we need quality of service? Well, we need quality of service where there's congestion at points on our network. This could be points of aggregation, where you have many PCs. Each one of these is a PC connecting in to a switch, and then that has one connection coming out. You could also have situations where you have a speed mismatch, where you're going from a gigabit connection, 1,000 megabits per second, down to 100 megabits. Or you could also have congestion when you go from a LAN to a WAN. You're going from your LAN onto a WAN across your gateway router here. Now, once again, this could be the speed mismatch, but you're going from a gigabit speed and you're going down to 100 meg speed. Quality of service takes in bandwidth, congestion, delay, and jitter as we look at this entire process. There are several types of delay we can get on our network, and there's several sources. First one is a code delay. A code delay is that amount of time that it takes to compress data. And we're using a compression algorithm. It takes computational cycles. That would be code delay. Next one is packetization. And that's another amount of time to encapsulate our packet with all the necessary header information. Then we have a queuing delay. And this is a variable amount. The first 2 are fixed amounts. This one is now a variable amount. In an amount of time that a frame or packet has to wait before it's transmitted. So the amount of time it's sitting in that queue. We have a serialization delay. And that's a fixed amount of time here that it takes to transmit a frame onto the wire. So we got to get it from the software onto the wire or copper. Then we have a propagation delay. And this here is also variable. And it's the amount of time that it takes the frame to travel between the source and the destination. It has to travel over that wire, and maybe it even has to travel through several different networks, several routers. That's our propagation delay. And then we have a de-jitter delay, and this is a fixed time here. And this is the amount of time to buffer a flow of packets and then send them out in evenly spaced intervals. So we buffer up a bunch of packets, then we stream it out in an evenly spaced intervals, so that way the destination gets an even stream of data. Without QoS, packets are processed as they come in. And when we have network congestion or variations in delay, which causes jitter, we experience packet loss. If you're trying to stream audio or a voice phone call and you're experiencing excessive jitter or variations, a playout delay buffer cannot tolerate it. And packets are dropped due to that excessive jitter. Too many packets dropped results in your call dropping out. With QoS, more voice packets are processed or forwarded because they're in the high priority queue, and it's been configured for 0 packet loss, which will still have some variations in delay. You'll still have some jitter, but an audio stream is still able to make up for that. And the playout delay buffer can send out a constant stream of audio information, resulting in a call that experiences 0 drops. It was my pleasure to provide you with this wonderful episode on network transmission quality. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.